Hello everyone. This video covers section 6.1, the standard normal distribution or random variable. This distribution is probably the most important one in the whole class, since the whole class is based on this at some level. Since this is a random variable, remember that means you need to have a mean and you also need to have a standard deviation. A standard implies that the mean has to be 0 and that the standard deviation is 1. The distribution can be normal without being a standard, but if it is a standard, which is the one we'll be using all the time, the mean has to be 0 and the standard deviation has to be 1. There are two ways to figure out probabilities here. You can use the table or you can use a calculator, and I will show you both ways. But before we do that, let's see what this distribution really means. The first thing that you need to notice is that this is symmetric. You can see this and these are the same. Since this is a random variable and the mean is 0, that means that the whole area has to add to 1. Remember, when you add all the probabilities, when you add everything, it has to add up to 1, which implies from here to here is 0.5, and from here to here is 0.5. You can think about this being x and this being y. So x can be positive or it can be negative, but y always has to be positive. So again, just keep in mind this, the whole semester, this has to equal to 1, which means this is 0.5, and this is 0.5. Now, let's say that this part right here is equals to 0.1. What does that mean for the rest of the graph? So that automatically means that this part has to be 0.4. Why? Because from here to here is 0.5. So if this is 0.1, that means this is 0.4. More importantly, that means that from here to here, all of this has to be 0.9. Why? Well, this is 0.5 plus 0.4, it will give you 0.9. Okay. First, I'm going to show you how to find this using the table, which will be provided in Canvas. And then I will also show you how to do this in a calculator, but you need to have a TI-83 or 84 to do that. Before I show you the table, I'm going to divide this into 3 colors, and that's going to make finding probabilities pretty easy. If the number is here, I'm going to call this the green color. If you have all the area from here to here, I will call that the yellow color. And this part right here will be the blue color. Notice how the blue is inside the yellow. That's very, very, very important. Also notice that there is no negative values, but this is symmetric. So that means that this part right here will also be the green part up to here. And from here to here will be the yellow part, and this here will be the blue part. The reason why we're breaking this into colors is this. The table doesn't care what you want. It's always going to give you the yellow color. If that's what you want, you're done. But sometimes you want the green color. You're still going to get the yellow color. So to get the green color, to get the green, you're going to do 1 minus whatever the yellow is. Remember, the yellow is whatever you get from the table. Now, if you want the blue color, which is this part from here to here, then it will be the yellow minus 0.5. And that's how easy it's going to be. And then if you want the yellow, well, that's just equals to whatever you get from the table. Okay? The table looks like this, and it is provided in Canvas. Okay? For example, let's say that you want to find the probability that z is greater than 2.45. Okay? So the first thing you need to notice is that greater than 2.45, let's say that 2.45 is here. Greater is this part. So that means that you want the green area. That's what you want. However, you look at the table doesn't care that you want this. The table is still going to give you this value. But you already know you want the green. Remember, the green is going to be 1 minus the yellow. So then we look to the table, and you look to 2.45. So 2.4 is here, and then you move all the way until you get to 5, and it's going to be this value right here, which is 99.29. So therefore, the yellow area, which will be the area from here to here, is going to be 0.9929. But remember, that's not what you want. What you want is the green area. So therefore, this will be 1 minus 0.9929, which is equals to 0.0071. And that's it. Let's say that instead the question was, what is the probability that z is less than 2.45? Now, this time is asking you just the area to the left, 2.45, which is all of this, or what we call the yellow area, which is what comes from the table. Well, we already know that that's equals to 0.9929, and again, that's it. Okay, finally, let's say that you are interested in finding the probability that z is between 0 and 2.45. All right, so this time, this is going to be the blue area. Why? Because 0 to 2.45 is this, which is what we call the blue area. Well, how do we find the blue area? Is the yellow area, which is what we get from the table, minus 0.5. And this will give you 0.4929. And that's it. Now, 95% of the time, you're going to have to find either the green area or the yellow area or the blue area. So 95% of the time you're going to be doing this. Sometimes you have to find two blue areas, like you have to find this part blue and this part blue. We're going to do that a few times in 6.2, but this is pretty much what you're going to be doing all alone. In the next page, I show you how to do this without the table, in case you want to use a TI 83 or 84. But to use the table, this is how easy it is. Let's try a couple examples now to make sure that we understand how to do this with the table. And then we'll try the calculator. So the question is asking you, what's the probability that z is greater than 2.21? So 2.21 is here. Why? Because 0 is right here. The first thing that you should do is shade the part that you're trying to find. So greater is this part. So you want the green area. So this is what you want. Remember, how do we find the green area? It will be the yellow area minus 1. So what is the yellow area? Look at the table, and we want 2.21. So 2.2 is here. And then you look to the 1, it will be this one right here. So this is 2.21, which is 98.64. Remember that that represents the yellow area. So this part right here is 0.9864. But the value you want is the green area, not the yellow area. So therefore this will be equals to 1 minus 0.9864, which is equals to 0.0136. So therefore this area is 0.0136, or that's the probability, which is around 1%. Again, just remember that the yellow area is what you get from the table. That's it. That's how simple it is to find this. All right. Now, what about part B? Part B says what's the probability that Z is less than 1.75. Okay, so less is this part. So now the part that you want, so what you want is the yellow area. Well, if you look to the table for 1.75, you should check this by yourselves now. This is 0.9599. Well, remember, you want the yellow area, you don't have to modify anything. So the answer is just 0.9599. And that's it. The next one is a little bit more tricky using the table, but it will help you understand the table very well. For now, we're going to break this technically into two parts. And for now, let's pretend that this doesn't even exist, which is still there. So therefore, that means that you have to focus on 2.21, and we did this part already in part A. Remember that this area, all of this, which is what we call the yellow area, was equals to 0.9864. Okay, but technically we want the area from 2.21 to negative 1.3. So that's pretty much what we want. So therefore, we're gonna break this into two blue parts. So we need to find this blue part first, and then this one second, and then we're gonna add the two areas. But for now, just pretend that this part doesn't exist. So we're only gonna focus from here to here, which we already know is 98.64. But remember from the beginning, very beginning, that from here to here is 0.5, and from here to there is also 0.5, because the whole thing has to equals to 1. So therefore, this blue part, how do we find the blue part? Remember, the blue was equals to the yellow minus 0.5. So if you subtract 0.5 from 98.64, that will give us 0.4864. So therefore, this blue part from here to here is 0.4864. Now, like I told you before, the table doesn't have negative values, but that doesn't matter. By symmetry, you can find the values. So if you look to 1.3, the area for 1.3, as you can see, is 0.9032. So that means that from here all the way to infinity, this is going to be 0.9032, which is the yellow area. But now the yellow area is going to be all the way from here to here, including this part. So if we use the same technique like the one we did to find this value. That means that if you want to find this blue area, all you have to do is subtract 0.5 from this one, just like when we use this one. So therefore this is going to be 0.4032. So therefore what we want are the two blue areas. So let's take a wild guess. What do we have to do? Just add both of them. So this will be 0.4032 plus 0.4864, which is equals to 0.8896. And that's it. Okay. All right. Finally, in this page, this one is slightly different. This one is asking you to find the probability that the area is between 1.27 and 2.71. So the part that you want is this. So this is the part that you want. Now, if you look to the table, the table is going to give you these values from here to here, which remember is the yellow area, and from here to here, which is another yellow area. The table says that this value is 0.8980, and this one is 0.9966. So therefore, to find what you want, all you have to do is do the biggest one, which is 0.9966, minus the smallest one, which is 8980, and this is equals to 0.0986. Now, how do we find this using the calculator? So let's redo all the problems using the calculator. The calculator requires something that is called a lower bound and a upper bound. So the calculator works slightly different. If this is the graph, then let's say this is the area you want. This part will be called the lower bound, and this one will be the upper bound. So you need to know those two values. So for example, if we try this problem again, clearly this one is the lower bound, and as you can see, this is going to infinity. So if you go to infinity, just use the number 1000, and if it is minus infinity, just use the number minus 1000. Okay, so this is how you do this in the calculator. First, you have to go to second, and then variables. By the way, these steps are also on the workbook. Once you do that, make sure you pick number 2, which says normal CDF. Make sure you use CDF and not PDF. Once you click on normal CDF, if you have a TI-84, it may be slightly different, but it's gonna ask you for the lower bound and the upper bound. So the lower bound is 2.21. The upper bound is going to be 1000 because it's going to infinity. And once you click enter on the screen, it's going to look like this, like normal CDF. The lower bound is 2.21. The upper one is 1000, and still give you exactly the same answer. Make sure that you leave the mean equals to 0 and sigma equals to 1. Remember, this is what makes this standard, so do not change that. And that's it. All you have to do is identify which one is the upper bound and which one is the lower bound. For example, for this one, you can see that this is going all the way. So the lower bound, in this case, the lower bound is going to be minus infinity or minus 1000, and the upper bound is going to be 1.75. So in this case, this will be normal CDF. The lower bound is minus 1,000 and the upper bound is 1.75, and it will give you exactly the same answer, which is 0.9599. Make sure you use the minus sign that is in this, not the negative sign. Okay? Now, the calculator is particularly very useful for questions like this one, for part C, because you don't have to break it into two parts. So you have a calculator. In this case, it will be just normal CDF. The lower bound is minus 1.3 and the upper bound is 2.21, and it will give you exactly the same answer, which is 0.8896. From now on, you are free to use the calculator or the table. It doesn't matter, you will get the exact same credit using either one. Okay? Now we're going to do the opposite or the inverse. These questions already tell you what the probability is. So your job is to figure out where these probabilities came from. For example, this one says that there is a value of A somewhere here, where the green area, because it's the area to the right, that this is equals to 0.025. So it's already telling you the probability. So we're going to reverse the steps. So that means that the area to the left, which is what comes from the table, is supposed to be 0.975. How do we find that out? Well, remember that the green was the yellow, 1 minus the yellow, so that means if you add the 2, it has to add to 1. And this is what I mean by reverse. Now, you're going to go to the table and you're going to try to find this value. Sometimes the value is not there, so you have to find whatever is closer to this. In this particular case, the number is here. So we're trying to find 0.975. And here it is. So 0.975 is here. This came from number 1.96. So therefore, the answer to this question is 1.96, which means, based on what we did earlier, that the probability that Z is greater than 1.96, well, it has to equal to 0.025. That's it. So you are just reversing the steps. But remember, since you're going to use the table, it requires that you know the yellow area. So make sure you know what the yellow area is. Okay. For example, here, part B, it's already telling you that there is a value of A somewhere here, where the area to the left is 0.90. So all of this is 0.90. Well, we'll do the exact same thing with it right now. Look to the table. And now we're trying to find the closest thing to 0.90. Well, 0.90 is not quite there, but it's between these two. So this is the closest you can get to 0.90. Actually, this one is a little closer, which came from 1.2 and A here. So therefore the answer would be 1.2A. It may be easier to look at this number like 0.9000 because the table uses 4 decimal places, so it may be easier to look at that way. You can find these values also using the calculator. The commands are very similar. It will be second variables But now pick number 3, which is inverse norm, and then you're gonna put the yellow area, or you can say the area to the left, and it will give you exactly the same answer. So for example, here if you write I and B norm and write 0.90, will give you exactly 1.28. Part C, you have to be a little bit more careful, because remember that from 0, this part is 0.5 and this is also 0.5. If the area to the left is only 0.2, that means the value for A has to be here. It cannot be here, because if it is here, it will be more than 50%. Even being in 0 already gives you 50%. So that means that the value for A has to be somewhere here, which means you have the green value equals to 0.2. But remember, the table doesn't work with green values. The table works only with the yellow area. But if this is 0.2, that means that this one has to be 0.8. And the only thing you have to keep in mind is that the answer is going to be negative. If you look for the value for 0.8, the closest you can get to 0.8 is this value right here, which came from 0.84. So hence, the value for A is going to be minus 0.84, because it's on the negative side. If you use the calculator, you have to use inverse norm and then also point A, and it will also give you 0.84, but since it's negative, just put the negative in front, and it will give you minus 0.84. The trickiest one by far is part C, but as long as you remember that you have to deal only with the yellow area, you'll be fine. This is what it says. It's telling you that the area between minus A and A, that is equals to 0.8. So technically, by symmetry, this blue area and this blue area, both of them have to be 0.4. It has to be 0.4. Why? Because this is symmetric, so you need to have the same area here that you do here. So 0.4 plus 0.4 is equals to 0.8. But remember, you also have a green area right here, which is equals to 0.1. Well, how do we know it's 0.1? Because remember, all of this is 0.5. So this is 0.5 and this is 0.4. Why do we need to do that? Well, because we need to figure out what the yellow area is. Remember, the yellow area is from here to here, or from here to here. Well, what is that area? Well, this is 0.1 plus 0.4 plus 0.4 is equals to 0.9. So therefore, the number you have to look for is 0.9, which we did already on part B, and the answer was 1.28. So hence, minus A is minus 1.22A. And that's it. The last thing we do in this section is called critical values. Technically, we did this already. This is gonna be 100% like the first example we did in the last page, like this one. It's exactly the same thing. The only difference is that it has a different notation. But we'll be doing problems only with this type. And this is gonna be very, very important in chapter 7, 8, 9, and 10. So this is just a different way of writing it. So the terminology or the notation is slightly different, but it's the same idea. Now, instead of calling this A, we're going to call it Z of alpha. So this will be Z of alpha, which is what we used to call A. This is still the green area. Now the green area now is going to be denoted by alpha. We still have the yellow area, which is what we get from the table, and that's going to be 1 minus alpha. So pretty much what alpha is going to be the area to the right all the time, or what we call the green area. And if it is negative, it will be on this side, but it's the exact same thing. So we did these problems already. So this is essentially this problem with a new notation. So what this says is this: there is C of 0.025. Remember, this is the value for alpha, where the area to the right is 0.025, which means the area to the left is going to be 0.975, and we already found this value to be 1.996. These numbers are going to be very important in chapter 7. All right, let's try one more. So now you have Z 0.005. So that means that the green area is 0.005. To find the yellow area, we do 1 minus that, which will give you 0.9950. If you look to this on the table, this will equals to 2.575 or 2.58. And that's it. Remember that you can also use the calculator to find this. So technically, to find these ones, all you have to do is second variables, and then you go to inverse norm 0.9950, and this will give you 2.58. And that's it.